Yes, hey fam, welcome back. Now let's solve 572, subtree of another tree. And if you have watched one of my previous videos, which was a binary tree tilt, then this problem will become really easy to you because it is like 99% that code itself with some minor modifications. As obviously you can copy that code and paste it over here. Now read through the question once. You'll be given a subroot and you are given a root and you have to tell if the subroot is actually present in the root. And just look at this test case. 412 is actually present in 412, but 2 actually has another node of 0. So subroot is actually not present in the root by itself. Yeah, it has some other values associated with also. Now, if it was like the subroot, it need not be that subroot must be in the same order. Like if this was also considered to be true, then it would be difficult to code up the solution. But since it is not uh, since that condition is not applied over here, the question becomes really easy to solve. And yeah, again, the time complexity of this will be of n square as yeah, it's not n square, it is n times n n times n plus the length of the number of nodes in the subroot. So number of nodes in the root multiplied by number of nodes in the root plus the number of nodes in the subroot. Mainly because you have to go through root once, and for each node again you have to calculate its subtrees and compare that with the subroot. So yeah, that's why it is number of node times number of root nodes, number of nodes in the root times the number of nodes in the root plus number of nodes in the subroot. Then again, you have to follow the same step. Have one level order traversal function which will traverse the the given root node or anything in breadth first search manner and store all the nodes. And yeah, and then you should have another level order function which will traverse the given root, and then for each node it will use the defined breadth first search, which is the level order function. And yeah, again it's pretty simple now. Again, read through the statement once, and if you see in constraints, yeah, it is given that there will be one root. So I don't think, yeah, since both are there, there is no need to add a guard clause over here. So yeah, you can directly jump into solution. So yeah, def level order takes in the node. Yeah, you can do any kind of traversal order. You can do post order, pre order, in order, vertical order, anything which suits you. But I like level order, so I'm going with that. I'm taking the node over here, and you should have the answer array. Then yeah, it is not like the perfect level order traversal. You have to make some minor modifications to it. So while this is the classic stuff, but now you have to make the modification to it, yeah, as follows. Yeah, if there is no node, then you have to continue. You might be like, but hey, you already checked for that in node left and node right. So I will tell you, we are not completely following the level order traversal formula. N U E, yeah, and before continuing, just append none value to the answer. It's not node, it is, yeah, you can append node also because node is actually none. Else you append the node dot value, and then now don't do node dot left and node dot right because you actually want the none values also. Yeah, if you consider this example, yeah, and if the given subroot was 4 2 with no one, and imagine this 2 was, yeah, let me directly make that subcase over here. Just uh, remove the 2 and make it 2, and the subroot was, yeah, and if this was the case, then obviously this is not present in the our root. But hey, if we don't do like this, and if we check for node dot left is equal to none and all, then our level order will be 4 and then 2. You don't want that to be the case. You want it to be 4 and then 2 none, and then you have to have none 2, because actually even if you have do not have a node, you should tell that there is no node present, mainly because you can't directly compare it like that. I hope you understood why. Or else you can do the classic level order traversal and check it out, and you will obviously get to know it won't work. So no, there's no need to check and all. Then you can directly append the node dot left, and directly don't append the node over here because you'll be stuck in an infinite loop. Yeah, And yes, this the level order traversal is done now. Always uh, make sure to check what you written. So we just print the level order traversal of the subroute. Let me reset the test case. I just print it out once. Be sure to debug your code whenever possible. And yeah, the tree is correct. You have 4 and then you have 1 2. One has no child, 2 and then one has no right child, left child, 2 has no right child, left child. So you have none of 1 and none of 2. So yeah, and then yeah, now 90% of the work is done. Yeah. Let's call that underscore sub tree tree, yeah. And now I hope you know what to do. Again, you have to go through the route, and for each node you have to do the level order traversal. So yeah, make sure that you don't do for I in. You can't do this mainly because you are actually popping stuff from the queue, and that will cause the length of the queue to change. So you have to do like this only. left. Yeah, pop left is actually a function. It is a method, so you have to enclose it in brackets or braces, whatever you want to call it. And now the subtree of this will be the level order traversal from the node itself. And if the subtree, it's not subtree, it's subtree, if it becomes equal to our underscore subtree, which is actually the subtree, which is actually the level order traversal of our subroute. Let me call it, yeah, subroute is already used. Let me call it underscore subroute. Yeah, if our subtree becomes equal to the underscore subroute, then you obviously have found your tree, so you can return true. Or else the again classic level order stuff. If node dot left exists, then you dot append the node dot left, and if node dot right exists, then and yeah, now it's pretty obvious that even after the level order traversal, if you don't find any solution, then you have to return false because the subroute was not present. Now yeah, let me just compare it once. And yeah, it is working. Yeah, let me reiterate, the time complexity of this is yeah, it is not that fast. And yeah, again, I don't know why these solutions are fast, because even they are doing the same thing. They are just recursively checking for each subtree. Yeah, if you see over here, they are checking for each subtree of node dot left, each subtree of node dot right. Again over here, each subtree of node dot left, each subtree of node dot right. I don't know why mine is slower and theirs faster. And yeah, let me talk about the time complexity once again. So the time complexity will be, you have to travel through each the subroute once. So it will be, let us call the number of nodes in subroute as m, and number of nodes in the root as n. Let me reiterate again. Number of nodes in the root is n. Number of nodes in the subroute is m. So it will be the traveling the entire subroute once. So it will be O of m plus traveling through each node in the root once. So O of n multiplied by the level order traversal of each node in the root, so which is O of n again. Mainly because if it was a complete tree, then you have to traverse each node again, and for each node you have to traverse the subtrees again and again. So it will be O of n square plus m. Yeah, so yeah, I hope you understood how the time complexity became O of n square times m. And yeah, so thank you. Grind more DSA, you can do it. No one might believe in you, but I believe in you. Yeah, thank you.